In the fluoride structure, coordination number of Ca2 plus ion is A4B6C8D3. Calcium fluoride has a structure of CaF2. It is an FCC structure with coordination number 8:4. So in fluoride, the coordination number of calcium is 8 and of fluoride is 4. So option C is the correct answer. To get a n-type semiconductor, the impurity to be added to silicon should have which of the following number of valence electrons? For n-type of semiconductor, impurity added to the silicon should have more than 4 electrons. So for n-type semiconductor, the correct option will be 5 electrons. The other semiconductor is p-type, for which the number of electrons should be less than 4. So option D is the correct answer. Diamond is a hard because A. All the 4 valence electrons are bound to each other atom by covalent bond. B. It is a giant molecule. C. It is made up of carbon atoms. D. It cannot be burnt. In diamond, each carbon atom is sp3 hybridized and linked to 4 other carbon atom tetrahedrally. By covalent bonds. As the atoms are held firmly by strong covalent bonds, so diamond is hardened substance. So option A is the correct answer. Which type of solid crystal will conduct heat and electricity? A. Ionic, B. Covalent, C. Metallic, D. Molecular. Metallic crystals are good conductor of heat and electricity or current because they have free streams of electrons in the metal. So they are good conductors, hence metallic conductors is the correct answer. Ratio of close packed atoms in tetrahedral hole in cubic close packing is: every constituent has 2 tetrahedral voids. In CCP lattice atoms, we can write 8 into 1 by 8 plus 6 into 1 by 2 is equal to 4. Therefore, tetrahedral void is equal to 4 into 2, which is equal to 8. Thus, the ratio becomes 4:8, which is equal to 1:2. So, option B is the correct answer. Volume of atoms present in FCC unit cell, face centered unit cell of metal is, where R is the atomic radius. In FCC lattice, effectively 4 atoms remain present in a unit cell. Therefore, total volume of atoms present in FCC is equal to 4 into 4 by 3 pi r cube, which is equal to 16 by 3 pi r cube as the total volume in unit cell. So option D is the correct answer. If AgI crystallizes in zinc blend structure with iodide ion at lattice points, what fraction of tetrahedral void is occupied by Ag plus ions? In AgI crystal, number of Ag plus ions is equal to iodide ions. However, the number of tetrahedral voids are twice the number of atoms forming the cubic lattice. Therefore, number of tetrahedral voids occupied by Ag plus ion is equal to 50%. So option B will be the correct answer. In the Bragg's equation for diffraction of X-ray, n represents A quantum number, B an integer, C Avogadro's number, D moles. Bragg's equation is n lambda is equal to 2d sine theta, where n is an integer 1, 2, 3, 4 and so on. So here n represents an integer, option B. Copper crystallizes in FCC with a unit cell length of 361 picometer. What is the radius of the copper atom? In FCC unit cell, 4r is equal to root 2 times a, where r is the radius of copper atom and a is the edge length. So r is equal to root 2 times a upon 4. Therefore r is equal to root 2 into 361 upon 4, which is equal to 127 picometer. So option B is the correct answer. The edge length of face-centered unit cubic cell is 508 picometer. If the radius of cation is 110 micrometer, the radius of anion is. The distance between the center of cation and anion is equal to d by 2, which is equal to 508 by 2, 254 picometer. So RC plus RA, which is radius of cation plus anion, is 254 picometers, or 110 plus RA is equal to 254. So the radius of anion will ultimately be 144 picometer. So option C is the correct answer. CSBr crystal has BCC structure. It has an edge length of 4.3 angstrom. The shortest interionic distance between CS plus and Br minus ion is A 1.86 angstrom, B 3.72, C 4.3, D 7.44 angstrom unit. So the closest approach in a BCC lattice is equal to half into body diagonal which is equal to half root 3a. We've given edge length is equal to 4.3 angstrom. So this is equal to 3.72 angstrom unit. So the closest approach will be 3.72 angstrom, option B. The packing efficiency of two-dimensional square unit cell shown below is A 39.27%, B 68.02%, C 74.05%, D 78.54%. So this is a given structure with radius this much is equal to R, and this whole length is equal to L. Therefore 4R is equal to L root 2. So L is equal to 2 root 2 R. Area of square unit cell is equal to 2 root 2 R the whole square, which is equal to 8 R square. Area of atoms present in one unit cell is equal to pi R square plus 4 pi R square upon 4. This is equal to 2 pi R square. So packing efficiency is equal to 2 pi R square upon 8 R square into 100, which is equal to pi by 4 into 100 is equal to 78.54%. So option D will be the correct answer. In a compound, atom of Y form CCP lattice and those of element X occupy 2/3 of the tetrahedral voids. The formula of the compound will be. So Y atoms are CCP and there are X atoms which occupy 2/3 of the tetrahedral voids. So Y is 4. So we can write X 16 by 3, Y 4, or we can rearrange the atoms and write this X 16 and Y 12. On reducing this we get X 4 and Y 3. So option D will be the correct answer. Number of atoms in 100 gram of an FCC crystal with density 10 gram per centimeter cube and edge length equal to 100 picometer is equal to. We know the formula. M is equal to rho A cube into NO, which is Avogadro number, into 10 raised to minus 30 upon Z. So substituting the values, we get 10 raised to plus 23 into 10 raised to minus 30 divided by Z, which is the number of atom, is equal to 4. So number of atom in 100 gram is equal to 6.023. On solving this, we get 15.05. So number of atom in 100 gram atoms is equal to Avogadro numbers divided by 15.05 into 100, which is equal to 4 into 10 raised to 25. So option E will be the correct answer. How many unit cells are present in a cube-shaped ideal crystal of NaCl of mass 1 gram? Atomic mass of sodium is 23 and chlorine is 35.5. So we can write as the number of atom 1 upon 58.5, which is the total atomic mass of NaCl, into 6.023 into 10 raised to 23, which is equal to 1029 into 10 raised to 22. A unit cell contains 4 sodium ions and 4 chloride ion. Therefore, unit cell is equal to 1.029 into 10 raised to 22 upon 4, which is equal to 2.57 into 10 raised to 21 unit cell. So option A will be the correct answer. Potassium has a BCC structure with the nearest neighbor distance 4.52 angstrom. The atomic weight is 39. The density will be, for BCC structure, D is equal to root 3 times 2 of A, or A is equal to, we can write it 2D upon root 3. On substituting the values, we get 2 into 4.52 divided by 1.732. So A is equal to 522 picometer. So density is equal to Zm upon A cube into Avogadro's number into 10 raised to minus 30. On substituting the values, 2 into 39 upon 522 cube into 6.023 into 10 raised to 23 into 10 raised to minus 30. We get answer as 0.91 gram per centimeter cube. Converting this into kg per meter cube, we get 910 kg per meter cube. So the closest value is 908, option D. Coordination number for copper is A1, B6, C8, D12. Copper has cubic closed packed structure, CCP structure. In this structure, one copper atom is attached to another 12 spheres copper atom in metallic copper. So the coordination number is 12 for copper atom. So option D is the correct answer. In the calcium fluoride structure, the coordination number of cation and anion are respectively. The calcium ions are arranged in CCP arrangement, that is, calcium ion are present at all the corners and that the center of each face of the cube. The fluoride ions occupy all the tetrahedral sides. This is 8:4 arrangement, that is, each calcium is surrounded by 8 fluoride ions and each fluoride ion by 4 calcium ion. So option B is the correct answer. If the radius ratio is in the range of 0.414 to 0.732, the coordination number will be. The radius ratio for coordination number 4, 6 and 8 lie between the range 0.225 to 0.414, 0.414 to 0.732 and from 0.732 to 1 respectively. So option C is the correct answer. In A plus B minus ionic compound, Radii of A plus and B minus ion are 180 picometer and 187 picometer respectively. The crystal structure is of compound will be A NaCl type, B CsCl type, C ZnS type, B similar to diamond. The radius ratio for cation and anion is equal to 180 divided by 187, which is 0.962, which lie in the range of 0.732 to 1. Hence, the coordination number is equal to 8, that is, the structure is CsCl type. So, option B is the correct answer. Ferrous oxide has a cubic structure and each edge of the unit cell is 5 angstrom. Assuming density of the oxide as 4 gram per centimeter cube, the number of ferrous and oxide ion present in each unit cell will be A 4 ferrous and 4 oxide, B 2 ferrous and 4 oxide, B 4 ferrous and 2 oxide, B 3 ferrous and 3 oxide atoms. Let the unit of ferrous oxide in a unit cell be N and molecular weight of ferrous oxide is 56 plus 16 is equal to 72 gram per mole. Weight of N unit cell is equal to 72 into N divided by Avogadro number. Volume of 1 unit is equal to length of corner cube, which is equal to 5 angstrom unit cube. So this will be equal to 125 into 10 raised to minus 24 centimeter cube volume. So density is equal to weight of cell upon volume. Density is 4.09, which is equal to 72 into N divided by 6 into 10 raised to 23. Substituting the value of weight and volume as 125 into 10 raised to minus 24. Finding the value of N, on solving we get 3079.2 into 10 raised to minus 1 divided by 72. On solving this we get N is equal to 4. So option A is the correct answer. A solid compound contains X, Y, Z atoms in a cubic lattice with X atoms occupying the corner, Y in the body centered position and Z atom at the center of face of unit cell. What is empirical formula of the compound? Atom X per unit cell is 8 into 1 by 8 is equal to 1. Atom Y per unit cell is body centered 1. Z per unit cell is equal to 6 into half, that is face centered, is equal to 2, 3. So the formula of the compound is X, Y, Z thrice. Option B is the correct answer. A unit cell of binary alloy composed of A and B metals. B is a small CCP structure with A atoms occupying the corners and B atom occupying the center of each face of the cube. If during crystallization of the alloy, if the unit cell of two A atoms are missed, the overall composition per unit cell is. Permitted coordination number for CCP is 8. But two atoms, A atoms, are missing. Therefore, coordination number of A is equal to 6 into 1 by 8 is equal to 6 by 8. Coordination number for B is equal to 6 into 1 by 2, which is face centered, is equal to 3. So, A can be written as 6 by 8, B 3, or we can write this as A6, B 24. Option D is the correct answer. NaCl crystallizes in same type lattice as does NaCl. Given that radius ratio of NaCl is equal to 0.55 and for radius ratio of KCl is equal to 0.74. Calculate the ratio of the side of the unit cell of KCl to that of NaCl. We have given as radius ratio of sodium and radius ratio of chloride is equal to 0.55 and radius ratio for potassium and chloride is equal to 0.74. So we can write this as radius ratio for sodium upon radius ratio of chloride plus 1 is equal to 0.55 plus 1. Similarly, with potassium and chloride, plus 1 is equal to 0.74 plus 1. Therefore, we can write this equation as radius ratio for sodium plus radius of chloride upon radius of chloride is equal to 1.55, and for potassium and chloride we can write this as radius for potassium plus radius of chloride upon radius of chloride is equal to 1.74. Now edge length of NaCl and KCl is 1.74 upon 1.55 is equal to Rk plus RCl minus upon RCl minus into RCl minus divided by Rna plus RCl minus, which is equal to 1.122. Option A is the nearest option and correct answer. Lithium metal crystallizes in a body-centered cubic crystal if the length of the side of the unit cell of the lithium is 351 picometer. The atomic radius of lithium will be. Lithium is body-centered metal, so we can write edge length and radius equation as a root 3 is equal to 4r. Therefore, r is equal to a root 3 upon 4, which is equal to 351 into 1.732 divided by 4. On solving, we get 151.98 picometer. So, option B is the correct answer. In orthorhombic, the value of A, B, C are 4.2 angstrom, 8.6 and 8.3 angstrom units. Given the molecular mass of the solute is 155 gram per mole and density is 3.3 gram per centimeter cube, the number of formula unit per unit cell is. We have the formula Z is equal to V into Avogadro number into density upon molecular weight. So substituting the values of volume as 4.2 into 8.6 into 8.3 ABC into Avogadro number 6 into 10 raised to 23 into density as 3.3 divided by weight as 155. On solving this, we get 3.84, which is nearly equal to 4. So option C is the number of formula unit per unit cell. Certain crystal produces electric signals on application of pressure. This phenomena is known as A. Pyroelectricity, B. Ferroelectricity, C. Piezoelectricity, D. Ferroelectricity. When polar crystals are subjected to mechanical stress, electricity is produced. A case of piezoelectricity. Reversely, if electricity field is applied, mechanical stress is developed. Piezoelectricity crystals act as a mechanical electrical transducer. So they are mechanical electrical transductor. So phenomena is piezoelectricity applying pressure. If NaCl is doped with 10 raised to minus 4 mole percent of SrCl2, the concentration of cation valencies will be 1 cation of Sr2 plus would create 1 cation vacancy in NaCl. Therefore, number of cation vacancy created in lattice of NaCl is equal to number of Sr2 plus ion added. So 1 cation produces vacancy for 1 NaCl. The concentration of cation vacancy on being doped with 10 raised to minus 4 mole percent of SrCl2 is equal to 10 raised to minus 4 upon 100, which is equal to 10 raised to minus 6 mole. Number of Sr2 plus ion in 10 raised to minus 6 mole is equal to 10 raised to minus 6 into 6 into 10 raised to 23, which is equal to 6.023 into 10 raised to 17 Sr2 plus ion. So option C is the correct answer. An element of atomic mass 100 gram per mole having BCC structure has unit cell edge of 400 picometer. Then density of the element is. We have the formula density is equal to N into M, number of unit cell into molecular mass, divided by A cube edge length, Avogadro number, into 10 raised to minus 30. So we can substitute the values. 2 into 100 divided by 400 cube into 6 into 10 raised to 23 into 10 raised to minus 30. On solving this, we get density as 5.188 gram per centimeter cube. So option B is the correct answer. When an electron is excited, molybdenum atom falls from L to K shell and X-ray is emitted. This X-ray are diffracted at an angle of 7.75 degree by planes with separation of 2.64 angstrom. What is the difference in energy between K shell and L shell in molybdenum assuming the first order diffraction? Sin 7.75 degrees 0.1349. So we know that 2d sin theta is equal to n lambda by diffraction. So lambda is equal to 2d sin theta. Substituting the value 2 into 2.64 as the separation into 10 raised to minus 10 angstrom unit, and sin theta as sine of 7.75 degree is the diffraction angle. On solving this, we get 0.7123 into 10 raised to minus 10 meter. So we have to find energy. Energy E is equal to Hc upon lambda. H is 6.62 into 10 raised to minus 34, Planck's constant. Speed of light is 3 into 10 raised to 8, which is also a constant value, divided by lambda, we just found out as 0.7123 into 10 raised to minus 10. On solving, we get energy as 27.88 into 10 raised to minus 16 joules. So option B is the correct answer.